All right, so this is a rational function warm-up, but it might help some of you who are having trouble with wholes. So this says, let's write a rational function that has a vertical asymptote at x equals 3, a whole at -2, a whole at 0, and a horizontal asymptote at y equals 0, and then find the coordinates of the two wholes based on the function you created. We're going to create the function together, so we should have the same function, so then we can figure out the wholes. So first, we got it y equals, we've got a rational function, so there needs to be a fraction bar. Let's just jump right in. So I need to have a vertical asymptote at 3. So that means that this function is going to have a factor in the denominator so that when I plug in 3, I get 0. So x minus 3 is the factor in the denominator because 3, when I plug it in, gives me 0. Now, if a function has a whole, that tells you that a factor divided by that factor is going to go away. That's what creates a whole. So if the whole needs to be at -2, then I need x plus 2 as my factors that I'm going to cancel, because when I plug in -2, I need to get 0. This one's a little bit tricky. It has a whole at 0. So that's just going to be a factor of x over itself. So it's kind of like having x on the outside of a parenthesis. You could also pretend that this is x plus 0 over x plus 0, because that just means x over x as well. And let's look at this third condition. This has to have a horizontal asymptote at y equals 0. Does this function have a horizontal asymptote at y equals 0? That would mean the denominator needs a bigger power than the numerator. And right now, yes, I've got a cubic function and I've got a quadratic function. And even when I cancel these two out, I'm still going to have 1 over a linear function. So the denominator is still going to be bigger. So this is going to be the function that I go with. So now it says, all right, so what is the value of your function, right? My function is really 1 over x minus 3 because these things are canceling, but this is the function I built, right, to answer this question. This is the function I'm going to use now to answer these two questions about the whole. So when I plug in the number -2, I get 1 over -5. So -1/5 is the location of that whole, -2 comma -1/5. When I plug in 0, I just get -1/3. So as you look at a graph, there'll be a hole at those two coordinates. All right, and then number 2, kind of our warm up together. Let's graph the following rational function. Be sure to include intercepts, asymptotes, and wholes, and then analyze the function. So let's see, we're going to do the y-intercept, the x-intercept, the vertical asymptote, and then the horizontal or slant asymptotes. This is partially factored. What would this factor into? So you may want to pause the video and see if you can do this example on your own and then come check your answers. This would be x plus 5 and x minus 3. I'm just going to write that x plus 1 there as well. And then in the denominator, I have x plus 3 and x minus 3. The x minus 3's cancel. So I do have a whole as well. And so my function that I want to look at is x plus 5, x plus 1 over x plus 3. So let's answer our questions about this function. Let's see, my y-intercept. So when I plug in 0 for all of these x's, I get 5 times 1 divided by 3. So 0, 5/3, which would be here on the y-axis. My x-intercept, I actually have 2 of them. One is at -5 and one is at -1. So there's -1, 2, 3, 4, there's -5. My vertical asymptote would be at -3. That's where this denominator is equal to 0. 1, 2, 3. There you go. And what else do I have to do? Oh, my horizontal or slant asymptote. I actually am going to have a slant asymptote. I have a quadratic function on top and a linear function on the bottom. So I need to do some division. When you do division, you need your numerator to be in standard form. So I've got x squared, 1x plus 5x would be 6x, and 5 times 1 is 5 over x plus 3. So to do the division, we're going to use the box method. We're going to put the x plus 3 down the side, and this is going to be x squared. This is my dividend, so this is going to end up inside the box. So I need to know x times x is x squared, x times 3 is 3x. This box plus this box has to add up to the 6x of my dividend. So how much am I missing? I'm missing 3 x's. Now when I add those together, I get 6 x's all together. So then the last part of my quotient is 3, because 3 times x is 3x. If I want to continue, 3 times 3 is 9, and I need a remainder of -4 so that those two boxes together will add up to the 5 I want in my dividend. So my slant asymptote is y equals x plus 3. That's my quotient, so that's my slant asymptote. So that starts at 3 on the y-axis and goes up 1 over 1, down 1 over 1. So here is my slant asymptote. So I can pretty much see, it looks like this part of the graph goes in this direction, and this part of the graph goes in this direction. And I have to do my whole. Where was this undefined? So this was undefined at 3 comma something, right? This was 3. I'm going to take my 3 and plug it into this new function. So I would get 8 times 4, 8 times 4, and then 3 plus 3 is 6. So what is 32, 6? 32, 6 is 5 1/3. So my graph should go pretty close to 3 comma 1, 2, 3, 4, 5 1/3 is right there. So there would be my, I didn't quite hit it. There's my hole in the graph at 3 comma 5 1/3. And the last piece is just asking you a couple questions. What is happening as x is going to the right side? What's happening to this side of the graph? Where's my function heading? It's heading to infinity, right? What about as x is approaching the asymptote -3 from the right side? So that's actually talking about this part of the graph. It's approaching the asymptote from the right side. It's going towards -infinity. So I hope that helped refresh some of the information you've learned on rational functions.